Okay, so in this video I'm going to solve problem number 77 from the book that I mentioned in class. It's to check if the function u of xyz equals 1 divided by the square root of x squared plus y squared plus z squared is a solution or not of the Laplace equation given here. So this is a second order partial differential equation. So all we have to do is take the second partial derivative with respect to each variable, so the x, the y, and the z, and add them up, and hopefully things will be 0. If it works, it is a solution. If it does not work, it is not a solution. So to do this, it looks like it's complicated, but if you look at it, the first thing I'm going to notice is that it's not going to, we don't really have to do all three partial derivatives. Notice that whatever happens to the x in my function, it's only in the denominator squared inside the square root, and has added a y and z, which are going to be constants whenever we take the derivative with respect to x. Then I'm going to do x again to get the uxx. But then look at the y shows up exactly the same way. The y only shows up in the denominator inside the square root, and it's squared. The z, the same. So whatever I do, I'm going to do it for x. And then whenever we do x for x, we know what the pattern is going to be like, so when we do it for z or for y. Okay, so we don't have to do the three partial derivatives, we have to do one of them and see a pattern. So let's start with ux. Okay, so let's go for it. So I'm going to do, of course, the partial derivative with respect to x. It's pretty simple. The x only shows up in the denominator. So this is like x something to the negative 1/2. So the denominator is going to be, the derivative is going to be negative 1/2 times that same thing to the negative 3/2, right? So I'm going to like x squared plus y squared plus z squared to the 3/2 in the denominator. And then there's a chain rule here going on, so I need to multiply by the derivative of x squared, which is 2x in the top. So that's it. So negative 1/2 times this to the negative 3/2 times the 2x. Now I can cancel the 2, and this really just is negative x divided by x squared plus y squared plus z squared to the 3/2 in the denominator. Okay, now that's easy. Now the second derivative, the second partial derivative with respect to x is, now I have to do a quotient rule, right? So the quotient rule, if you don't remember it, I'm going to write it over here in the corner. It's if you have a function divided by a function, and you're taking its derivative, it's the denominator squared, not derivative, okay, squared. Then the derivative of the top times the bottom minus the derivative of the bottom times the top. This is a little bit problematic with this part because some people forget that when you take this derivative of g, you don't read g as a negative power. It just take of g as a function. Okay, so don't interpret it like it's g to negative 1. No, it's the derivative of g. Okay, so in this case, my f is x, or negative x, and my g is this x squared plus y squared plus z squared to the 3/2. So let's go for it. It's not that complicated because the denominator is this thing, so it's going to get squared, which is okay because then it's just to the 3rd power, right? Now the derivative, I'm going to do the derivative of the top, the derivative of f. In this case, it's x, so just negative 1, right? Negative 1 there. And then multiply that by the bottom, so just copy the bottom. X squared plus y squared plus z squared to the 3/2. Then minus the derivative of the bottom times the top. The top is a negative x, so minus a negative x, I'm going to make it a positive x here, right? Times the derivative of the bottom. So derivative of the bottom, remember, don't interpret like a negative power just as it is. So the 3/2 is going to come down times the same thing to the power minus 1. So it's going to be 3/2 minus 1 is to the 1/2. And then again, I have a chain rule, so it's the derivative of the inside, so it's going to be times the 2x. Okay, cool. Okay, so the first thing here, it looks a little bit complicated. It's going to simplify a little bit. That 2 with that 2 is going to cancel. I'm going to combine those x's. So I have 3x squared, I believe, right? So let's put this together. So this becomes, I'm going to do a little bit of an extra step here, which I really don't need, but I'll do it one more step. I have a negative, just to clean this up a little bit. So this to the 3/2. Then I'm going to have plus 3x squared times x squared plus y squared plus z squared to the 1/2. Denominator is x squared plus y squared plus z squared to the third power. Okay, so now what I'm going to do is factor this. I have x squared plus y squared plus z squared to the 1/2 right here. I have x squared plus y squared plus z squared to the 3/2. So I can think of this 3/2 power right here like 1/2 plus 1. So if I factor x squared plus y squared plus z squared to the 1/2, my other factor inside is negative x squared plus y squared plus z squared to the power of 1, right? Because 1 with this 1/2 over here and this 1 here, I'm not writing it because it makes it confusing, would be the 3/2, right? For this first thing. And now I factored this part, so that part just becomes plus 3x squared. Okay. So by doing that, it's going to make this very cool because the denominator has exactly that same factor to the 3. Okay, so this is the same factor as this, so I can cancel, and in the denominator, I really just get x squared plus y squared plus z squared to the 5/2. And this guy is not there anymore. And then on top, look at what I'm going to have. I have negative x squared, negative y squared, negative z squared, plus 3x squared. So when you put this all together, it really becomes a positive 2x squared, a negative y squared, and a negative z squared, divided by x squared plus y squared plus z squared to the 5/2. Right? Okay, we're done. That is my uxx. Okay, that is it. And it's great because, like I said, using the symmetry, we can know that the u, let me write it in color, let me do it green. The uyy, I don't have to do it again. I know the same thing is going to happen. Only what's going to happen to the x is going to happen now to the y, which means I'm going to have a positive 2y squared. And whatever happened to the x and to the y and the z's are going to happen now to the x and the z. So I'm going to have a negative x squared, and I'm going to have a negative z squared. And the denominator is going to be the same. And who is going to be, I don't like that color. Let's try to use that. Green. Okay, let's try to use, okay, let's use that color. If I do uyy, sorry, uzz now. Now, the z is going to be positive. I'm going to have a negative x squared and a negative y squared. This is not cheating, okay? This is noticing that if I repeated the same steps with the other variables, the same thing is going to happen. So there you go. If you add these three terms, right? If you add these three terms, you have the same denominator, and you have two positive x squareds and two negative x squareds, right? You have two negative y squares and two positive y squares, and the same for the z. You have two negative z squares and two positive z squares. So when you add them, it's 0. Okay, so we did it. It is a solution, and we're done. Okay, so I'll see if I can make more examples and post them.